Lesson 8.2, Parabolas. We're going to focus on parabolas today, and we have done parabolas before, but now we're going to look at some more detail. If you remember in the past, we would graph parabolas by looking at certain characteristics, usually the y-intercept, and we'd reflect it over the line of symmetry. We'd know that we'd find the vertex, and that was enough. But we're going to graph these without using the y-intercept this time, but it involves some other pieces. Now, if we review briefly here for a moment, the line of symmetry is the dotted line that goes through the vertex. Here's some new pieces that we're going to emphasize in this lesson. We still have the axis of symmetry, but now we also have what's called the directrix, and these two are perpendicular to each other. We have the vertex still, but now we have what's called the focus. And then we have a line that goes through the focus, perpendicular to the line of symmetry and parallel to the directrix, and that is called the lattice rectum. Okay, interesting name, but I will refer to it from this point on as LR. Okay, so you don't get a chuckle every time I have to say it. Now there's formulas for all of this stuff, but these are the pieces that we're going to look at. We're going to look at that LR because that's going to tell us if it's going to be a narrow parabola or a wide one. Before, we usually use the y-intercept to help us, but that's what we're going to work with now. The directrix comes into play when we say that the distance from the focus to any point on the vertex is going to be equal to the distance from that point on the parabola to the directrix. They would be equal distances. So from here to here would be the same as from here to here. Vertical line, of course. And we'll look into that more closely as we go. Alright, now there's two types of equations. Okay, here's standard form. And if you remember, in standard form, we could decide if it's going to open up or down. If it was positive, it was going to open up. If it's negative, it's going to open down. We could tell that this was the y-intercept. But to find the line of symmetry, we had to use a formula. And to find the vertex, we had to find out the line of symmetry, x value, and plug it in and find the y value. So it wasn't very useful for finding vertex. But this form is called the vertex form. In the vertex form, it tells you what the vertex is. It's going to be this value and this value. The constant, however, the y-intercept, we have to find by plugging in a 0 for x and find out what it would be. And we're going to, again, do this later, don't worry. The a value still tells us if it opens up or down, same rules. Positive it opens up, negative it opens down. Then we can find our line of symmetry because it's going to be the same thing as our x value. Now look at this equation here. It's solved for x, which means this one's not going to open up or down. It's going to open right or left. Okay, again, if it opens right, it was positive. If it opens left, it was a negative. This one has, it's still considered vertex form, but we have to be careful about how we take the information from the equation. And we'll have an example like that later too. So what we're going to do is we're going to complete the square and remind ourselves of how we did that. Because standard form is good, but not as helpful as vertex form. So let's take a look at this equation. Now we're going to complete the square. Now to do so, if you remember, we're going to focus on this part because this is the part we will complete. I cannot complete the square unless the lead coefficient is 1. So I have to factor a 3 out, which gives me x squared plus 8x. And I'm going to add something to that trinomial that will complete it. Then I have my 50 out here. And to keep the equation balanced, if I add something to one side of the equation, I can add to the other, or subtract from the same side. If I add it, I can subtract it, and it remains balanced. Now, how do we complete the square? Well, we take this term, our x coefficient, we divide it by 2 and square it. Sorry. That gives us 8 divided by 2 is 4, 4 squared is 16. Now I can't put 16 in here because if you remember, we had to be careful. It's in parentheses, so if I took it out of the parentheses, I'd have to take it times 3. If I took it times 3, I'd get 48. So out here, it's actually 48. Alright, now I didn't have to write this part, so I'm going to take this off here. Because my next step is to factor it. Now it's a completed square, so I can write x, it's plus here, so I'm going to say plus here, plus plus is plus plus, half of 8 is 4. And over here we have 2. Now this is considered vertex form. And from this form, we know that the vertex is negative 4, 2. Notice that these are opposites. And the y's are okay. They're the same. From this we know that the axis of symmetry is x equals negative 4. Notice it's the x value of the vertex. And 3 is positive, so we know it opens up. And that is completing the square, and we're going to need that later. Now here we have a question that has a y squared in it. The last one had an x squared. Since it's y squared, we're going to solve this one for x. So I'm going to start this by taking 4x, adding y squared to both sides, and now I'm going to complete this one. But I'm not going to divide by 4 yet. If I divide by 4 right now, I want to have a bunch of fractions, and that's going to make things a little more difficult. So I'm going to wait and bring the 4 over at the end. So let's do this part first. Alright, so I'm going to add something and subtract something. So 2 divided by 2 squared is 1. Again, the 2 came from here. So now I have 4x equals, and this is now a completed square, so y plus plus is plus plus, half of 2 is 1, and then this gets put together. Now, here's where I will bring 4 over. I'm going to divide both sides by 4, and that gives me x equals 1/4 y plus 1 squared plus 3. So this is how we would write it. We have to divide these two, and divide these two. But we can't get inside the parentheses because of the square, so it can just sit out front. We're going to use this equation later, so it's good that we did it now. This ends lesson 8.2, part A.